Last one here we have is going to be the rectangle. Prove that these 4 points make a rectangle of the coordinate plane. So just like the other ones, we're starting with a nice label diagram, just so we can talk well about it. Also, you'll see I kind of laid my points down here for reference. So the first thing we do is first convince ourselves that this is actually going to be a rectangle, meaning we have to reference the definition. In this case, the definition means a rectangle is a four-sided shape, which is intuitive, but we have to show that all the angles are right. So to show they're right, I think what we're going to have to do is use slopes. Perpendicular slopes mean right angles, because by definition, perpendicular has to meet a right angle. So that's all we really have to do. Let's convince ourselves first so these are actually going to be perpendicular. Let's just find some slopes. And we can do it very easily on the coordinate plane. Now, this is not how we're going to prove it, of course. This is just for us. So right now, we have a rise of 2. We have a run of 1, 2, 3, 4, 5, 6. So that's going to be a slope of 2 over 6, which is just a third. So we have one slope. Let's check out its partner slope on the right. Looks like we have 1, and then we drop 3. And so our slope in this case is going to be negative 3 over 1. Now, if you compare these two slopes, we have 1/3 and then 3 over 1. Excuse me, negative 3 over 1 because it's decreasing. That is, by definition, an opposite reciprocal because 1/3 has been flipped. So the 3 is now on top, the 1 is now on bottom. And then it went from positive to negative. That, that guarantees that this angle is going to be a right angle. Let's go ahead and check the other pairs. Let's see, we have 1, 2, 3, 4, 5, 6, up 2. So that's just like the one on top. It's parallel to the one on top, so its slope will also be 1/3. And then we have down 3 over 1 for this guy on the right. So again, it looks like in all cases we're going to have right angles because the slopes are all opposite reciprocals of one another. Now that's not proof. This is just like planning out your proof. Proofs have to be formal. They have to be based in calculation. They have to go with nice statements. So let's go ahead and write that statement. It seems like we have all the pieces we need. I've been calling this a statement of intent. This is important, of course, because it tells the reader what you want to do and how you know you're right. It also tells your teachers that you know what you're doing, even if you might mess up a calculation down the road. So let's go ahead and write it. Let's decrease the size of that pen. Okay, so to see. Okay, so to prove ABCD is a quadrilateral, I will show that, let's see, AB is perpendicular to BC. BC is perpendicular to DC. DC is perpendicular to AD. And AD is perpendicular to AB. Now let's tell the reader how we're going to do it. So we're going to do it by using the distance formula. And now how we know we're going to be right. So to show they all have opposite reciprocal slopes. And let's put an exclamation point because that's our last one. So now let's go ahead in the middle here. Actually, let's do it right here. Let's remind everyone what the slope formula is all about. Okay, so the slope formula is just rise over run. Another way to look at that is change in y over change in x. That's probably the more common way. And in the same breath, we can remind ourselves that change in y calculation is just about subtracting the y values between 2 points. That will show the change in y. Change in x will be x1 minus x2. And so that's the calculation we're probably going to perform over and over again for each one. So let's go about the business of actually calculating some slopes to prove that they're actually opposite reciprocals of one another. Now, organization is key here, so let's just start by labeling AB, and we'll do the work of AB right here. Okay, so let's do this a little bit, just so I can see my points. So AB, change in y over change in x. Going from A to B, we're going from 0 to 2, so it's be 0 minus 2. At the same time, going from A to B, we have negative 3 subtract 3. So let's do a little cleanup here. That's negative 2 over negative 6. That's the same thing as 1/3. Now that's not surprising because we actually found that was going to be the case up here. Um, right here we found that's going to be 1/3 going from A up to B. We did that using a slope triangle, but again in the proof we want something a little more formal, and so we have our calculation to back up our thinking. Let's see. Let's go BC. Again, let's go change in y over change in x. So BC goes from 2 to negative 1, so 2 subtract a negative 1 on the y values. At the same time, we're going from 3 subtract 4. So 2 subtract a negative 1 is a positive 3. 2 negatives make a positive. 3 minus 4 is negative 1, which means I'll just have a negative 3. Again, I'm going to point out we knew BC was going to be a negative 3. We actually knew it in our count. Right here from B down to C, the slope ended up being negative 3 over 1, of course, but that's reducible down just to a 3. And so far so good. We found two slopes. We know they're opposite reciprocals, and therefore that's a perpendicularity. Let's keep going. Let's find CD. So change in y over change in x. So looking at the coordinate values that I've written at the bottom of the screen, change in y from C to D goes from negative 1 to negative 3. And then change in x goes from 4, subtract a negative 2. Negative 1 subtract a negative 3, the same thing as negative 1 plus 3, which is just a 2. On the bottom, I have 4 subtract a negative 2. Again, this is adding, so that's going to be a 6. And so that reduces to 1/3. Okay. Again, no surprise. It's actually written right here. B to C, we found it to be 1/3. So one left to go. Hopefully this will turn out to be a negative 3, but let's check it anyway. So we have CD, so we need AD. Okay, so the change in y over change in x for AD. A goes from 0 to negative 3. And then on the bottom, we have negative 3 subtract negative 2. Yeah. Oh, I have it backwards. Let me back up. So change in y goes from 0 to negative 3. Yeah, okay, and then on the bottom we have negative 3 subtract a negative 2. There we go. I switched up my numbers. So two negatives make a positive, that's a 3 on top. These two make a positive, that's a minus 1 on bottom. And so we have a negative 3 for overall slope. Yeah, sorry about that. I messed up my numbers. It happens. And so we definitely we're seeing just what we said in our statement of intent, that we want to show these are parallel, perpendicular, excuse me, by looking at proving they have opposite reciprocal slopes, which they all do. And so that's good to go. Let's look at the secondary proof that we're being asked to make. We're asked to prove diagonals are congruent. Okay. So to prove diagonals are congruent, let's go ahead and mark in our diagram first, what we're talking about. So we're going to try to prove BD is congruent to AC. That feels like the distance formula to me, but let's go ahead and write out what we're intending to do. Okay, so to prove AC is congruent to BD, I will show that they have the same length. Using the distance formula. Okay, so let's remind ourselves what the distance formula is all about. In this case, the distance formula is equal to x2 minus x1 squared, y2 minus y1 squared. That, of course, is just a derivation of the Pythagorean theorem. We can also look at this as just delta x squared plus delta y squared, which is my preference, and that's what you're going to see here in the video. So we have the points labeled right above us, right above this statement. And so let's just mechanically go about finding some distances. So let's talk about AC. Going from A to C goes from -3 to 4 on the x. So -3 to 4 is just a distance of 7. 0 to 1 is just 1 squared. So we have this distance to be very familiar, square root of 50. And so if we can show that BD does the same thing, man, are we in business. So BD. Going from B to D goes from, BD goes from 3 to -2, which is a 5. And then goes from 2 to -3 on the y's, which is also just a distance of 5. 5 squared is 25, 5 squared is 25, and so that's just the square root of 50. So just like our statement of intent said, we want to prove these are congruent by showing they have the same distance, and they do. We have square root of 50 on AC, square root of 50 on BD. Notice I'm not taking an opportunity to reduce that. That's not the point of the problem. I'm just trying to show they're congruent, which I did, and that's it. All right, guys, that's video 5. That's the end of this. So if you're watching these, it means you're willing to prepare for this quiz really well. And so what we're expecting to see is all the stuff you're seeing here. A nice, well-labeled diagram, probably with some marks on it because you're using it to figure some problems out. A nice statement of intent that tells us basically what the definition is that you're trying to meet, how you're going to meet it, and how you know you're going to know you're right. And then backing that up with some nice calculation. It's going to be something formula-based. It's got to be something more than just some logical explanation. We want to see a calculation that proves your point. Now, if you want to add some conversation in there, you want to add some explanation or words or logic, that's fine. Just know that you have to have that calculation too. All right? Guys, that wraps it up for me. Thank you.